In this lesson, we're going to talk about the dot product and properties of vectors, as well as finding the angle between two vectors. And so, first thing that you need to know is there is something called a dot product. And the dot product of two vectors is defined as a1 times b1 plus a2 times b2. And we'll do an example with that shortly. Also, there's an angle between the two vectors, and that you can find by this equation. That's cosine theta, the angle that you're trying to find, a dot b. So that's the purpose of finding the dot product. And then the magnitude of a times the magnitude of b. Other properties of vectors continue. Some of these don't really come up too often. However, you'll see shortly that this does in the proof to find out what the cosine of theta is. So to find the cosine of theta, you would actually use the law of cosines. And the law of cosines can be set up like this, and this is the one property that is used in order to simplify and eventually end up with the angle. The cosine of the angle is equal to this. Now, one thing that you may remember is the cosine of 90 degrees. So the cosine, the cosine of 90 degrees is equal to 0. And you can see that by this graph. This is the cosine graph. This is 90 degrees. That's where it's equal to 0. But this is important because if you know that the cosine of the angle is equal to 0, then you know that the angles are going to be perpendicular. And that gets into a property up here as well that says that if you know that the dot product between a and b is equal to 0, then vectors a and b are in fact orthogonal. And orthogonal is just a fancy name for saying perpendicular. All right, so we understand that there's something called the dot product, and we know we can get an angle between two vectors. And I know that if the dot product equals 0, then I know that the angles are, or the angle between two vectors is orthogonal. Let's do a couple examples. First of all, finding the dot product. Vector u dot vector v is equal to, and it's just the product of the first two parts, like the change in x's. So 2 times negative 12 is negative 24, and then plus 4 times 6 is 24. That gives you 0, and the question is, are they orthogonal? And the answer is yes, because you know that the dot product is 0. You could do the same thing over here. U dot v, again, looking at the product of the first two and the product of the second two, and therefore that dot product is negative 54, which means no, they are not orthogonal. Just a little reminder, finding the magnitude. The magnitude is going to be written as, where you have a kind of an absolute value, that's the context, and that's going to equal 9 squared plus 3 squared, or the magnitude of a is equal to 81 plus 9, which equals square root of 90. Taking a 9 out as a 3 square roots of 10. And you're going to use that to find the angle between two vectors. So, for example, if you want to find the angle between this, you're going to remember that the cosine of the angle between the two vectors is equal to u dot v over the magnitude of u times the magnitude of v. So first of all, I'm going to find the dot product. 7 times negative 3 is negative 21 plus a negative 60 over, now I'm going to take the magnitude of u, which is going to be 9 plus 25, times the magnitude of v, which is 49 plus 144. That means that you have a negative 81 over, let's see, this is going to be square root 34 times the square root of 193. Now, once you have this written, now the question is, well, what is your theta? And the theta, you know it's going to be an obtuse angle because it's negative. It's equal to the cosine inverse of this particular number. And you would just do that on your calculator, and that's what the question is asking for. What is your theta? So this finding the cosine of the angle requires you to understand how to use the dot product as well as what the magnitude is of each of the vectors. And then you have to remember to do the inverse of both sides to get your final angle. That angle is what it is because the cosine inverse will give you an obtuse angle if it's negative, and it'll give you an acute angle if it's positive.